I'm going to show you how to make an ohm meter PCB attachment for your Arduino kit. First, let's open up EagleCAD. EagleCAD is a circuit board and schematic entry program. And the way you open this, it's installed on most of the FabLab PCs. You can download it for free yourself. You click on the Start button and type the word Eagle, and then you'll click OK whenever it pops up with the icon. And this control panel window will pop up. From here, we can start a new project, schematic, board, library, cam job, etc. The only things we're interested in are the schematic and the board. What I want to actually do here is create a schematic, and from the schematic we'll build the board. So first we have this confusing looking panel on the left hand side. We're going to click this button. If you mouse over, it tells you what they do. We're going to click this button to add a part. And it takes a while for this library to load sometimes. I'm going to click in the search and type resistor. And what you're looking for is a resistor that has a schematic symbol, which looks like this and is in this window, as well as a PCB symbol, footprint, as they call it here. And in the footprint, you're looking for something that has a large pad that you will be able to solder to. So some of these are surface mount, and you can tell the scale by looking at this little scale bar. So this is 2 millimeters. That's going to be too small. So we're looking for something that will be more like a through-hole component like this. So we'll search through and find a good resistor value. If you install the SparkFun library, they have a really good set of resistors, usually. And in fact, I think that's the one that I might use, because that is going to be similar to what you have in your kit. So I will use this 5 millimeter value here that says axial 0.5 from the SparkFun library. I'm going to click OK, and I'm going to drop that on my schematic. The next thing I need to do is, as I had mentioned, we're building the ohm meter board. So the ohm meter board works as a voltage divider. You have an unknown resistor, R2 in this case, which you're going to plug in and measure the value of in a voltage divider with a known resistance, R1 in this case. So we can connect these two things together with a wire. Click on one point to the other and double click to end the wire. And we also need the VCC, or the 5 volts, the ground, and an analog output. Sometimes this can be kind of confusing. So we just need to find a test pad to add to this. So it says there's the test pad, test pin library, TP, and I'm using TPPAD1. And this is what it will look like on the schematic, and this is what it will look like on the actual board. So I'm going to click OK. I'm going to put one here. I'm going to right click to rotate, put one there, right click again and again to rotate, and put one there. If you didn't right click to rotate, you could use this rotate button and click on the item. Once it's connected to a wire, you would have to delete the wire in order to move it around. I'm going to go back here and change the value of these points. I'm going to click OK here. Actually, let's change the name. So this name, I'm going to click, and I'm going to call it 5 volts. This, I'm going to click and call analog underscore out. And this I'm going to call ground. So this is my schematic. All I have to do to create the board now is click this button, generate or switch to board. It says, do you want me to create this from the schematic? And you say yes. So now it puts your items in a random configuration here. Your job is to put them within this space with the black outline. So you're going to click the move button, put this here, and what you could actually do is right click to rotate and try to build your board as simply as possible. So you want your ground coming over here, your 5 volts coming over here, and your analog pin can be coming out of either the bottom, the top, the side, wherever you would like it to go. Once you've done this, you can actually change the dimensions of your board. And I'm going to drop this down, and we want this to be just the right size, as small as possible, but without being too small. So in fact, what I will do is I will move this analog value there, and I will shrink the board this direction. Now I need to wire up these wires. You can see I have this very thin net connection, as they call it, here. In order to do that, I am not going to click on wire, I'm going to click on root. And I'm going to click from one piece. It's going to highlight the parts that I need to connect to it. Once I've connected it, it goes away. Do the same down here. And here, I can connect up to this, and then I can connect to that. Now the way this board works is you will actually solder your R1 value here. You'll then solder a wire here, and here, and here, connecting these to the appropriate outputs and inputs that they're labeled. The R2 value, we're going to need to just touch to an unknown resistor. So you can solder wires to this as well, or you can use this this fill tool to draw a rectangle over the test points. And what this will do is basically when you need to touch, oops, I'm going to delete that and make that actually a copy of that one. You just need to touch your resistor, your unknown value, to this. And this will change the voltage of this voltage divider, and that will change on this analog output. This analog output then will be read into the Arduino and scaled from, the 0 to 5 volts is 1024 different steps. It will be scaled and you know how many volts per step, and you can backwards calculate using the voltage divider formula to find out what your what your R2 value is. And so once we've done this, we need to make this into something that our machine can actually mill. And so our machine mills using images, black and white images. For that, we need to come over here to the layers settings, and we're going to remove all the layers. We're going to say none, and then we're going to click the ones that we want to add back. So we want to add back the pads and bottom layer. Sorry, we also need the dimension layer. That's the box around it. From here, we go to File, Export as Image. We want to use about 600 dpi, monochrome, and we're going to browse to an area that we want to put this. Once we have that in place, we can, if we can find it, we can open the image and view it. So what we want to do is follow the next video that will show you how to use this to mill your circuit board on the Modela. There's also some web pages that you need to view to get the gist of what's going on there. But that should be it. Once you've created your board, what you should do is open it in GIMP. So edit with GIMP. If you right click, it might take a moment for GIMP to load because it's a large program with a lot of plugins. So be aware that that might happen. I'm going to pause the video until it actually is fully loaded. Okay, so after about 3 minutes, GIMP is finally loaded. What you want to do is create two files. One file is going to be your cut file. That's going to cut your traces. So the drill bit's going to come in where my mouse is here and cut around all of these traces. And what that does is it separates all the wires. The next thing we're going to do is create the board outline. And that's going to cut your board completely out of the larger part of the PCB. You may not have to do this if you're given a small board. You may just have to zero your machine and cut the traces. When you zero, you typically want to zero down here, the bottom left corner where my mouse is. So the first thing that I would like to do is I want to invert the image. So I'm going to go to Colors, Value Invert, and now this edge is the thing that will be cut. And in fact, I don't even believe I need this dimension line. Like I said before, the circuit board may be cut to size for you. And if not, you can actually cut it to size in a different manner. So I'm going to use the bucket tool, and I'm going to fill this area so this entire outline is gone. So now I'm going to save this. Here's a trick with GIMP. You can't save a GIMP file as a normal thing. You have to So it'll save it in as GIMP files. You have to export. So export as, and I'm going to name this board 2 PNG, just so I'll be able to tell the difference. And I'm going to click export at this point. Everything looks good. And I'm going to discard changes. This is just telling me that I didn't save it as a GIMP extension. So now, when I go into my folder, I have, this is the original board file, and then this is the file that will get cut. The next video will show you how to actually take this file into the fab modules on the laptop connected to the Modela machine and affix a board, use the drill bits to actually mill out the outside. Again, you're probably not going to be cutting the dimensions out, so you can skip those steps. You'll only need to use the 1/64 inch bit and cut out just around these edges.